Good
Jerry,
evening, everyone. This
who
is
drew uh
your.
who, who drew that photo? Did you draw it yourself?
Oh, yes, that was
Oh,
my self-portrait.
nice.
I think I did it in 2014, about
Well,
10 years ago, a decade
oh,
ago.
you haven't aged a bit.
Uh, I hope so. Hmm. Yeah, I participated in art classes between, let's see, pre-elementary school to high school. I think so, yeah. It was my weekly hobby session. Sometimes it's good to have a hobby so that you have some life beyond school and work. All right, this is your weekly dose of business analytics. Has everyone been okay in the past week? Oh,
Yeah,
okay.
yeah,
I heard someone
sure.
smiling or laughing. I don't know whether it's a good sign or not.
We're a little sore from economics.
Oh, economics? Wait, is it another course or are you talking about some part in our
No, we have another
school?
course right after yours with
Oh, really?
it's
Okay.
got a nice little test end of the day on Saturday. So
This week or
yeah, this
last
past week
week?
we had a test. Yeah.
Oh, I see. Well, economics was one of my favorite. I am assuming that you're learning microeconomics, right?
Correct.
Yeah, that's somewhat more um, straightforward to me. I also learned the macro version about the national level. To me, it's not so familiar as individual level economics. But it's a good source for developing theory background, which is usually a starting point for doing data analysis. All right, let's get started. What are some outstanding questions, and where do you find it to be most challenging or unclear in our week 3 already? Yes, study.
I did have a
Hi.
question on, is it possible you could pull up a simple linear regression model from the homework?
Okay, so you that was Daniel, right?
Correct.
You would like some demonstration of how to do a linear regression model in Excel?
Uh,
Is it
not
good?
how to do it, but
Okay.
more if you could just cover a few points that we were taught in the class. I don't know if anybody else wants to hear
I
that.
see.
I'd appreciate it.
So you already know how to implement the operations in Excel to generate
Correct.
the outcome, but
Correct.
you're not sure whether you understand the whole procedure or the individual elements of a regression
Individual,
output
yeah,
table?
correct, exactly.
Oh,
The
I see.
individual elements, correct.
Oh, okay.
Some of the
I'll
individual.
point you to resources for that. Are there other parts that you have found challenging or unclear?
No, I think I got a fair grasp on it, but I just like on question 2, it asks us to develop a linear regression model, and I just wanted to see if
All
you
right.
could point to some
Great.
like the coefficients and stuff, the R square, and just kind of explain a little more.
And I have a
How
follow
about
up
other
on
students?
I have a follow up on 1B with Daniel.
And
Like it
this
says,
is Anthony. Okay.
yep. 1B, it says, develop your model. So I wrote the model. Then the next question, the sub question says, what are the values? It's kind of a weird question. Does it mean, if you could explain what that's asking for, because
Oh, okay.
I just gave you the equation and it's asking me what the values are. Am I supposed to repeat it again? I didn't understand that.
Yeah, because it's giving, I think it's looking for the slope and the, I guess the X and the Y, I guess that's what it was
Okay.
looking. That's what
All
I
right.
put on the paper. I don't know.
I just put it on my notes. How about other students?
Sure. I think we're saying a
Hi,
version of the
Susan.
same thing. But yeah, a part of that too is I know the answer for the homework, but I would like to better understand what is the slope of the regression line, just how that comes into play. Like I have the slope, I know what it is, but I don't understand.
Correct.
other than
Okay.
it's where I was told to look.
Got it. That was Stephen. You would want to know more about how to interpret a slope, right?
Got it.
If we have time, can you show us how we can use Excel for multiple regression model?
Multiple regression model. I believe that will be content for next week per se, but if time allows, let's see. Yeah, I'll try to see whether we can do that. It seems possible since we have another example here. Okay, shall we get started? If you do not have other outstanding questions, you want particular attention from me?
There are two in the chat.
Oh,
One-
right. Okay, thanks for reminding. I haven't.
No problem.
I haven't checked that. Okay. Let me go through them to make sure I know the focus of our review session today. Okay, what are the slopes better for regression line? That was what Stephen asked. So just a hint, usually the slope we call are, well, usually beta can refer to something different that's called standardized coefficient. I can also discuss that later, which is different than what Excel automatically shows. Okay, there's another one, but I can explain by example the difference between matching coefficient and Jaccard coefficient. I have used Jaccard coefficient myself. Yeah, let's get started. So first, in our question 1, we got a simple linear regression case. So in this one, we can learn some of the questions that you cared most. What are the linear regression elements? And what it means by asking for a regression equation value, and what the slopes can be interpreted in. Yeah. So when we have a linear regression model like this, can you give me a reflection whether you have already know enough about how to get a summary output table for a linear regression in Excel? Did you encounter any difficulty in generating a linear regression model? Any other students? Okay, I feel really glad that you did this part really well. So in this table, there are 3 components. There's a regression statistics, there's a ANOVA table, and here is a table for the coefficients. I have found a really good source for how to interpret and what are these individual elements for. How to interpret each component of a regression summary table. There's a tutorial particularly corresponding to an Excel example. So feel free to read it. In this, you will find that it really well interprets every single part in an Excel output file. So there's multiple R squared, adjusted R squared, all explained here. But you can find this link in my, wow, okay. I really hate this when the shared screen has a part covered by the Zoom buttons. Anyway, yeah, you will be able to find this in my shared review session notes. It's in the simple regression section of homework 3. And you will be able to find a link to the review session notes in our Canvas page modules. And you go to the top, you will be able to find it here in TA office hours. Nevertheless, let's take a look at some parts that might be really useful. first I would point out the multiple R. If you find that this multiple R is simply equal to a coefficient of correlation in this case, we can calculate it here. So if we want to calculate a correlation coefficient between these two parts, square footage of and the price, we will find that this exactly equals to this one. This is also part of the property of the such statistics. And if we square this R, we will get R squared. That's why it's named R squared. So for example, let's test. If we square this statistic by raising it to a power of 2, then we find that this equals to this one. So that's how the R squared is generated. So this multiple R can be also understood as the correlation between the original dependent variable and the predicted value of the dependent variable. You can testify this by generating the predicted price. So this brings us to also echoes to a question from Anthony about how what regression equation values are. Simply the question intends to ask us how to interpret a regression model using regression equation. And we can also use this regression equation to generate predicted values. So let's do both parts of that. Given this output table, we already know the R squared part. And this ANOVA part, I don't believe it's required for any questions in this week's homework. However, our resource link I found has a very good section for this ANOVA part. That's about testing the overall significance of the regression model. So I encourage you to read this page. I have linked in this week 3 resources here. Then the most useful part for prediction is, however, lies in the coefficients. So using these two parts of the coefficient, you can know the regression equation can be written as price would equal to an intercept, which is 64,000, about that much, plus, well, if you need to round it, the slope. Slope is simply the coefficient of a predictor variable, where the coefficient of intercept is usually just called intercept. So here we write in the slope of size. Okay, then you can add the predictor here, which is the size of a house. Sometimes you find the regression model includes a error term. Sometimes not, because when we generate a predicted value, this error term is taken a value of 0, so it won't really change. It won't go into the predicted value because of what we assume the error to be. As we learned in the lectures, the error has an expectation of 0. So when we predict price from size, then we assign 0 to the error term. So using this, we can know how we can generate predicted price. We take advantage of this output of the simple linear regression. So we start from the intercept. Well, let's use the functions. And remember, this intercept doesn't change over all the observations. So we should give it an absolute reference by giving it, by putting the dollar signs in front of both rows and column indexes. And we will do the same with size. So we need to make sure that this size coefficient is also absolutely referenced. Then we need to time it by the individual size. This should be relatively referenced. So we know that this is the predicted price. I calculated this by using the estimated intercept and estimated slope, and also substitute the x value by the individual observations of the predictor. If we are doing a multiple regression, then we need to do this slope times predictor by multiple predictors. However, in this case, we have only one predictor, that's the size of the house. Then we simply autofill everything. I recall one student previously asked, well, why there's some pound signs. This simply because the width of the column is not wide enough to show all the digits. So if you want to show everything, you just double click the right border of the column, then it shows all the whole width of the column. Then with this, let's make another test. The correlation between price and predicted price. Correlation between array 1, that's the price observed, and array 2 would be the predicted price based on our estimated simple linear regression. And you find that this, okay, let me increase the number of digits. This exactly equals to this one, which is the correlation between the price and the size. Is it somewhat surprising to you or not?
Yes,
Yeah.
it's
Yes, it's
Would someone try to give an intuitive interpretation why that the correlation between size and price equals the correlation between price and predicted price?
Because it's the same slope.
it's saying that the variation of the dependent variable is close. It's capturing the independent variable is capturing the dependent variable by what's inputted.
Mm-hmm. Oh, I really like this interpretation. Who was it?
Daniel.
Oh, hi, Danny. Yeah, so I think an intuitive interpretation would come exactly this way. So we build this model from understanding the relationship between size and price, right? So we predicted price using exactly size. So size captures all the information we require to understand the price according to our model. So therefore, the predicted price contains exactly the same information as size, because this predict price, as we go to the regression equation or the formula we use to generate such predicted prices, we immediately notice that this the predicted price is generated exactly using size alone, plus the coefficient we estimated. So either size or predicted price would contain essentially the same information about price. That's
It-
why the correlation between these two sets would exactly equal to each other.
Hey, Jerry, I thought I understood it until you put in predicted price. What's the difference between price and predicted price on the like A2? It's 1942 square feet,
Hmm.
and that's 765,000. Why do we have a predicted price of 575? Where's that coming
Mhm.
from? I thought we already had
Okay.
the price.
So let's go to the regression coefficient again.
Yep.
When you asked what it means by, let me take a look at the exact wording of the question again. What are the values of the regression equation? So first, we should understand what a regression equation contains. I think I include notes somewhere. Okay, regression equation, yes, here. I encourage you to read these again later, but I would point out that a regression equation calculates a predicted value using the model parameter estimates, means the estimated intercept and the slopes, and thus contains no error symbol or error term. And no specific value of a predictor or error should be used to specify the regression equation. And we should also note the difference between a regression equation and a regression model. Most of the time, they are written in different ways. In regression equation, we do not have the error term, so it gives the relationship between the predicted value and predictors. On the contrary, a regression model usually has the error term, so it specifies both the deterministic component and the error component.
Hey, you know what? I have a
Is
different
it-
question though. It's why are we
Okay.
trying to find a predicted price if we have an actual price?
Very good question. The reason why we have this predicted price has multiple folds. So it depends on the reason or the purpose we do regression. First, using this regression model, we can predict the price or the expected price for a new case of house. So if there's another house that's on the market, but it does not exactly match any of the size we have here. For example, we can calculate another one, let's say 2,500. I don't believe any of the case has exactly the size. But with this model, we can still make a predicted price. So we can predict using our regression model for the cases that are not observed in our sample. And there are other occasions that we can use this model. We can also understand the relationship between the size and price by running this model.
Is this,
And this predicted
Jerry,
price is a side product. Hi, there's another question.
I'm sorry, yes, well, I don't know if that answered Anthony's question. I don't want to,
I think it did. Basically, if I understand it right, all the data is coming up with a formula that has a predicted price, regardless of what they've sold for.
Mm-hmm.
That's
Yeah,
what I'm
exactly.
assuming. But if you wanted to replace that 1942 square foot home, the new target would be 575.
Mm-hmm.
If you wanted to find
Exactly.
something similar. Is that what it says?
Yes, using
Okay.
this model, it tells that the predicted price for a size of this much for our first case is somewhat lower than the actual price. But this difference between the price, the observed price, and the predicted price goes into the error term.
Okay.
And if you go through our textbook or the lecture videos, you notice that the whole process of generating the coefficients was done through minimizing the sum of squares of the error term. So we are minimizing the error term. All right. Was there
Yeah,
other
there was,
corresponding questions?
yeah, it
I
was,
just
can you,
demonstrated how we can generate predicted values.
okay, I guess I wanted to ask my follow-up. So can you pull that back up?
Of the Excel file. Yes.
Oh, yeah. So intercept, is that the coefficient of intercept, is that the fixed cost? And the variable that's given, the independent variable that's given as size in square feet, is that's a cost per the 262, is it for 1 square foot of home? Is that what it's telling us?
Oh, sure. Okay. Yeah. So in the interpretations of the coefficients, you got the latter one correct, but the intercept, I don't believe it doesn't seem that you got the correct interpretation. So let's practice each of them. For intercept, it's really important to understand this intercept may not always have a meaningful interpretation. So it means, so mathematically, this intercept means when all the predictors in our model equal 0, exactly 0, what would be the predicted value for the dependent variable? So in our case, since I already wrote our regression equation here, so if we how could we get a value exactly equal to intercept? That's when we assign 0 to the size predictor, right? If we time 0 with this coefficient of size, then this term goes away, and all we have left in our model would be the intercept. So here, the intercept essentially indicates that for a house that has a 0 size, 0 square footage, 0 square foot of size, the predicted price would be would be 64,000. But obviously, we would know that there's we cannot really sell a property or a house of 0 square footage. So that's why I said the intercept does not always have a meaningful interpretation. But there are ways that we can make the intercept more meaningful. This can be done by manipulating the size. So instead of running a regression from the raw square footage, we can do it by centering this size predictor by subtracting the mean value of size from all the observed size. Then using another output of the summary, then we would find that the intercept would indicate the mean price instead of a price at 0 size.
Okay.
Was it
Sorry,
straightforward to understand?
Yeah, I'm sorry. So
Okay.
you're saying it's a mean price, the 64,500 basically. But if you could look
Sorry, excuse me. No. What I said earlier is that the 64,000 was a predicted price when the size equals 0 square foot, which does not have a meaningful interpretation in this case. But we can transfer the model to another version where the intercept can be meaningful, but that cannot be done until we manipulate or change our predictor into another version.
Okay, can you look at problem 1E?
Okay, let's see.
And see what the price do you get? Because I'm not sure.
Oh, I think I already got the first one. Okay. Yeah, so we can also predict the value for the second one. So where did you have any unclear?
Well, I mean, are you adding the 64,000 plus the price per square footage equal, and then times the square foot of the home?
Oh, sorry, I was lost. I'm not sure what the procedure you described sounds like. But to predict the price, follow what we did earlier. We use the regression equation and the coefficients like this.
That's not what that question is asking, though.
Okay. What was your question?
On 1E, it
Okay.
says, what selling price would you predict for the home that is 2,500 square feet?
Okay.
Can you show us that formula, or what are we supposed to do there? Or
yes, sure. I set up the formula like this one. I predict the price using the coefficients, including the intercept. This is the intercept plus the coefficient of size times size. So for a new value of size like 2,500, we predict again using exactly the same formula. Here, what's different is the value we substitute for the size. So we insert a new value in place of the size. So using the same principle, we can, predict another case for a house with a size of 2,600 square foot.
Okay.
Then using exactly the same regression equation, we can calculate the predicted price of this house.
Well, that answers my question. Thank you.
Ah, excellent.
Okay, and I agree. Thank you for that explanation. But you're not taking into account the error in this case, right? We leave that off for this particular problem.
Could you say the last part?
Yeah, just the error in the formula for price. We wouldn't apply that here.
So no, we don't know anything about the error because in our original data set, we have only these two columns, size and price, right? We did not observe any error term. So we cannot use error to make predictions. We could only assume certain properties of the error to make predictions. So here, the particular assumption we have about the error is that it has a mean or expectation of 0. So when we make predictions, we say that on average, the predicted price would go like this much. And this predicted value applies to the predicted population. So essentially, it tells us that if we can sample our Orange County houses again and again for 1,000 or millions of times, we would observe that the average value for a house of 2,500 square feet, the price would be on average this much. The error term would be averaged out.
Gotcha. So, it's a great. We don't have. That's just understood then, because I know I added the error into my response, but it sounds like we don't need to do that. It's just it was a text term, not a number term, so we're okay dropping that off.
Yes, particularly if you make predictions for a specific case that are either in the sample or not, then you must assume something about the error, which assigns a 0 value to it.
Okay.
Okay, there are some questions in the chat room. Let me go through some of them. Do we include residual value in the values of regression equation? No. Do we just use correlation function to get correlation coefficient? Yes, we can. Are there other ways we can get correlation coefficient? Can someone remind me? I used the function of correlation coefficient like this. Oh, okay. Food asked a question whether it's okay to say that the price is the actual values while predicted values are on the regression line. Yes. Difference between actual and predicted error. The difference between actual price and the predicted price is the error. Yes, and here the error can also have an adjective referring to it by predicted error or the estimated error. Okay, predicted embodies the error, hence you won't need to add the error. Well, the predicted price does not really have any error term in it, so we would know that this predicted value time plus error would be the price. So if we calculate predicted price, this can be generated while doing the regression. So there are options in the regression output window that you can ask to generate the predicted price or predicted error term. This would be price minus predicted price. Let's understand some part of predicted error. As it shows here, because it has dollar signs, so it's in the accounting format. So the negative values would have parentheses around them. So we notice that this error has both positive errors and negative errors. And the mean, let's calculate a mean average. Okay. What do you think the average error should be? Any guess?
0.
Good guess. It's exactly 0. So let's increase the decimal places so you understand that it's not because of rounding. And what about let's see, standard deviation? Well, standard. Which one is standard deviation?
STD, I think.
Okay,
yeah.
it's this one. What do you think the standard deviation of error would be? You could actually find it in the regression output. It's this much, about 160,000. It's, oh, interesting. Wait, did I apply it correctly? Yes.
Did you grab the 0?
I think you should get the population, not the sample.
Let's see. I don't believe that's the reason. No. But it should be this much. Let's see. Are there any errors I made? I don't believe so. Interesting. Did I miss any part? Okay. Standard. Right. Well. Oh, I see. Okay. Maybe I would go from some of okay, let's see. Yeah, so I was trying to bring up how we can calculate this standard error. This is not exactly standard deviation for this standard. It's not standard deviation for the error term, but it's the sum of squares for the errors divided by the degree of freedom. So from here, we understand that the mean value of error terms exactly equals 0. right. What are some other outstanding problems that's worth solving?
So Jerry, I do apologize, and I was kicked off the internet for about 20 minutes, but that
Oh,
if you covered what is the slope beta of a regression line, I'd be really interested in your thoughts on that, because I did just use a coefficient. And it sounds like you said that's not exactly a beta.
yes, I pointed out that because in some other publications or textbooks, beta is specifically reserved for standardized coefficient. A standardized coefficient can be still done through our linear regression operation, but we must manipulate the price and size, or the independent variables and the dependent variable before running the regression. That's to standardize each of them using the standardized function by subtracting the mean and divide by the standard deviation of individual variable. So
Gotcha.
beta usually refers to a standardized coefficient, but in some publications, they don't make such differentiation. However, when we talk about coefficients, it's usually the raw coefficient before any standardization.
Gotcha. Well, the publication I'm referring to is the homework. So
Oh, okay. Let's see.
should I use the
didn't-
coefficient or the standard? It's part 2A.
Yes, just use raw coefficient as
Okay,
what
gotcha.
we acquired before running any standardization. However, I did include some part of the standard coefficient. Maybe I reserved it for next week. So let me check. Standard. Oh, okay. Oh, standardized coefficient. It was in week 2, but that's in the Beyond Course section. So if you would like to know
Gotcha.
more about standardized coefficients, you can refer to my notes I made in our last week discussion.
Awesome. Thank you.
So quick question, this is Adam speaking.
Hi,
What's the
Adrian.
interpretation for the slope, the coefficient?
Oh, I see. Oh, right. I think I stopped somewhere in the intercept, but I didn't go further to the slope. So to interpret the slope of 262.8, usually for values above 100, we do not really worry about the decimal places. We take integers. So about this 263, as well, there was another student who gave a really good interpretation earlier. That means for every increase in the square foot by 1 square foot, well, for the increase in the square footage by every 1 square foot, the expected price increase by $263. Yeah, we need to take care of the unit of measurements.
Got it, thank you. And
Okay, did you follow?
we don't have to worry if it's reasonable or not, right?
Did you were you concerned that it's not reasonable?
That's the only concern that I had.
Why do you think it's unreasonable?
Oh, it's $200, $262, right?
Uh-huh.
Okay, my bad. I read it like 200,000. So I was like, that doesn't make sense. to
Yeah,
me.
so that's why I made a note saying that it's very important to look into the unit of measurement. So here we already know, okay, selling price and square footage, and here the price is in dollar, size is in square foot. So make sure you consider them while modeling. There was another question in chat area by Mark saying whether, I think it updates. Akila, whether beta, the standardized coefficient, is the same as R square. No, and this R square is, I have never seen it referred to by R square score, so just call it R squared. Coefficient has nothing to do with R squared. As you can see here, R squared must be a value between 0 and 1 because it's multiple R, a correlation coefficient, squared. So because this correlation coefficient can only range between -1 and the +1, when we take a square of any value, it must be a positive, well, non-negative result, right? So the R square would only range between 0 and 1. This adjusted R square, I also made some notes about adjusted R square in my review session notes. It's beyond the course section, so I encourage you to read them once you complete the homework.
Hey, Jerry, just to clarify what you're saying, could you say correlation coefficient is R and coefficient of determination is R squared?
Yes.
Okay, thank you.
Correct. As I demonstrated earlier. Are there questions regarding the other two problems?
Can you show the formula for predicted price? Can you click maybe on row C2?
Yes. This is exactly as reflected on a regression equation. If you understand how a regression equation can be written, then we should be good with predicted values. And also using the predicted using the regression coefficient, using the regression equation, we can also understand the relationship between predicted value, observed value, and the error term, as it goes all here.
Can you also click on, like, I guess, the predicted error? I just want to see the formulas that you were using to calculate. Yeah, okay, just there we go.
This comes from the regression equation.
Okay.
Because here in the regression equation, well, probably I should make it clear by saying it as observed value. Observed price would equal to this times size plus predicted error. How about this? Probably that's clearer.
There we go.
Okay. Well. So we can apply the same technique for predicting stock price changes. Oh, I see. That's why there's a beta slope. I see. Well, the beta here is the raw coefficient. Oh, I
Jerry,
see.
on problem 2,
Mhm.
I got stuck on, okay, so I figured out I did the regression model. I figured out what the slope was of the regression line. I got like 0.94, I don't know, 0.9 something. What does that say about Microsoft? It totally makes sense to me about every square foot. It is an increase in price on the other model.
Mhm.
But when we're talking about percentages, and then, so what are we saying? For every percent change in the S&P, Microsoft returns 0.9? I'm saying I've got that wrong.
Yeah, I think what you said is right, but let me make sure. So in this data set, originally we have 3 columns, right? But we need to calculate the change in the price between 2 months, right? Let's see.
Which they gave us that in
Okay.
our data set. So we had that.
Oh, already? Okay.
Yeah, it was easy. Yep.
So upon that, we have this output of the regression model with an intercept and a change in S&P price index to predict the price change in Microsoft. So remember that when building this model, the predictor is this change in S&P price. And this change is calculated by a ratio or fraction of the previous and the consecutive price. So it's a fraction. And we use this fraction to predict the fraction change in Microsoft. So as you just said earlier, this coefficient of 0.94 or 0.95 after rounding is it can be interpreted exactly as what we did in the home price case. For every let's say percentage change in S&P stock index, stock price index, the expected change in Microsoft stock value was 0.95%.
Hey, Jerry, I just want to make sure I understand that. I think it's different. Isn't it saying that Microsoft has less volatility compared to the S&P 500? So it'll perform 9.5% better in down markets and 9.5% less in up markets. Isn't that 9.5?
9.5 in not percent. So no. If we must compare the volatility of S&P and Microsoft, it would entail a hypothesis testing, because here this value of 0.95 is an estimated coefficient. It has sampling error associated with it. So the population parameter of the coefficient could include 1 in it. So if we test whether this coefficient equals 1 or not, we will learn this technique later in the hypothesis testing block of our course. But yeah, here I would like to note that this value, if we want to compare whether this coefficient equals 1 or not, it entails a hypothesis testing. Just because we observe the estimated value of the coefficient is 0.95, it's not sufficient to either support or deny any evidence of whether the coefficient equals to 1 or not. So in terms of what you said earlier of 9.5%, I don't believe we can interpret it that way. The coefficient here directly says that when S&P increased by 1% in their stock price, Microsoft would increase by 0.95%. And if S&P decreased by 1%, then Microsoft also decreased by 0.95%.
Thank you. I appreciate you putting that into English.
Is that 0.95%? Or are we going to say 95%?
Oh, okay, good question. Let's understand it. So short answer is 0.95%. Given 1% change in S&P. Was this clear to understand?
Jerry, when you run that regression model, are you using columns D and E or using different columns?
Yes, I use column D and E.
I am getting different numbers than you using columns D and E.
Some parts that's worth checking is whether observation matches. So if we have 119 observations, so remember we are calculating the percent change, right? So this change out of 120 months, we can only have a change of 119. There's, one period short because we are taking difference.
So we omit that last one that has no value, they're blank, correct?
Yeah, because here, this percent change was calculated by taking difference between these two. There's no observation following this one. So that's why it's not possible to get percent change anymore.
Hey, Ben, in regards to your, the regression, the independent variable, or the x-axis, which one are you using for the x-axis?
Oh, good question. What did you use? What do you think?
I use S&P.
Yes.
The dependent
Sorry, got
is
it correct.
Microsoft, right?
Yeah. So usually we put the independent variable on the horizontal axis and the dependent variable on the vertical axis.
And the
I
question,
have my axes like in the center of the scatter plot.
Sorry, excuse me. What did you ask?
Both axes are in the center of the scatter plot. They're not like on the
Oh, I see. And then I
left-hand
encourage you
side and the
to.
bottom. Is that a problem? I didn't know how to change that.
You could change that, but it won't really change the shape of the pattern, right? It's just where it intersects. So I encourage you to look into Google in such questions. It's really useful. So Excel, scatter, plot, intersection point. Well, it pops up. Then you can set the coordinates of intersecting point of two trending lines. So there are other people that have similar questions.
Thank you, Jerry.
No problem. Okay, there are additional questions in the chat area. Let me go through them. While you can also review your answers in homework 2 and let me know whether you have additional questions. Okay. Yes, Adam. Yes, I think his name might be pronounced as Adam. In other words, predicted value of the dependent variable is usually called y hat. Yes, you will find this in equations in probably our textbook and some other textbooks. I showed where you can find my notes. It's in the module tab in Canvas page.
Gary, on the first one for homes, you showed basically how to calculate the how to get the correlation, the 0.78. How did you calculate for the R squared again? I know it's squared taking the correlation, but can you show me how you did that again?
Yes, R squared is automatically generated in the linear regression operation. But I calculated again to help you understand how this R square was related to some other statistics. So as I showed here, this R squared is nothing but the square of the multiple R. And this multiple R is the correlation between the observed price and predicted price.
And then on the bottom portion of that, the difference, how you showed that it equaled that correlation. How did you show that on the bottom of either it was C or I think it was C?
Were you talking about these two?
Yeah, so you just did correlation on that one and then it calculated for that?
Yes, this correlation is between column A and B, size and price. And this correlation is correlation between column B and C, the observed and predicted price. They are exactly the same.
Okay, thank you.
My pleasure. Oh, I see.
Can you show the formula for D 56 160,000?
D56. Let me go there. 56. Yeah, I was just showing that the standard deviation of the error term is not the same as the standard error for the regression.
Is that because you use the sample versus the population?
No, it's not. It's because the way to calculate them they are not calculating the same thing.
Oh, okay.
Yeah, so this standard error is calculating as in the textbook shown as the square root of the error term.
Oh, got it. Okay.
How about last question, last section?
Okay. So what was your question?
I think it's question 3, section C.
Okay. Section C. Which of these two coefficients would you use and why? Okay. In part B, we need to calculate matching coefficient between two people. And in the second part, part B, it's Jacquard coefficient. Okay, let's go to it. Okay, here. So we have 4 variables, but 2 subjects. And when we calculate a matching coefficient, we need to code whether they match or not. So for a matching coefficient, well, I'm not allowed to make any notes here, right? We just find the number of variables where these 2 cases have exactly the same value. So on gender, they are not the same. On citizenship, not the same. But on shopped with retailer or before, yes, they are the same. Drive domestic car, neither of them did, so they are also the same. So from here, we have 2 out of 4 variables where these 2 subjects have exactly the same observations. So that's why we would use the number of matched variables divided by the number of total variables to calculate a matching coefficient. Did you get it correct for matching coefficient calculation?
Yeah, and
Okay.
the other one.
Jacquard.
Yeah, over 2 instead of 4. But which one would I use that I didn't find in the handout?
Oh, I see. Okay, so how do we choose between these? What about some tentative questions? Other students, any ideas? How did you address this question? How did you choose between matching coefficient and Jacquard coefficient?
Class. I guess on mine, on the first one, matching coefficients, they take in, obviously, Jacquard does not count zeros either in the numerator or in the denominator, is my understanding. And for matching coefficients, they do. So the only one that, so for instance, using the matching coefficients, like you were saying earlier, male, female, obviously that's would be a 0 for Anna and a 1 for Joe. And for the next one, that was also a 0, 1. And for shopping with retailer before, that was up as 1, and the next
One and
one.
one? Okay.
And domestic drive was a 1. So
Oh, sorry. Excuse me for that part. If we coded in a way between 0 and 1, then that's for these two cases, it'll be both 0 to represent no.
but it's a match.
Yes, they match, but when we code it using 0 and 1, no, it's usually represented by 0.
Okay. So yes or no is either, it's either true or false, basically, right? Or yes or no.
Yes, correct.
Okay. So
But you made a good point. For Jaccard coefficient, we would ignore or not include the variable that have matching zeros. So when we code whether a person drives domestic car using yes and no, yes would be represented by 0, and no would be represented by 0. Yes would be represented by 1. So we would not account for domestic car driving when calculating Jaccard coefficient. So yeah.
The matching coefficient for the 1 would be 50%?
Yes.
0.5, and then
0.5,
for
yeah.
the card would be 1, or there's only one match, right?
Yes, there's only one match, but no, the Jaccard coefficient won't be 1.
No. So it's, what is it?
So when calculating Jaccard coefficient, as we discussed earlier, it won't account for the variables where both or all the subjects have have matching zeros. So we would ignore the variable for driving domestic car. However, this leaves us with 3 variables. So we would check how many matching do we observe among these 3 variables. We see that we have only 1, that's whether shop retail or not, and they match on this variable while not matching on the other 2. So we divide 1 by 3. And because of these distinct properties between Jaccard coefficient that does not account for matching zeros and matching coefficient that does include matching zeros. So the choice between these 2 would depend on how much it matters to include or not include matching zeros. So that brings us to assessing what it means by driving domestic car. So remember, no matter whether we are using the matching coefficient or Jaccard's coefficient, we are assessing what? The similarities between subjects, right?
Correct.
Both of them are similarity coefficient or similarity index. So the choice between them essentially depends on the quality of a similarity it assesses. So if it actually measures similarity, then it's a good choice. But if does not really indicate a good similarity, then it's not. So in this case, in my understanding, driving domestic car can be some similarity to represent the choice or preference for the US brands versus international brands. But when people choose car brands, the similarity it reflects is usually from specific brands of cars, right? When we talk about car brands, it's either it's not usually to look into whether it's US brand or not. So if we want to go deeper into whether these 2 people are similar in terms of whether they both choose a specific brand, for example, BMW or Nissan, then it does not give us a good quality in that sense. So if we depend on that, then it tells us that the matching coefficient includes a variable that does not have a good quality similarity measure. However, if we believe that measuring similarity by simply whether a person chooses domestic brands versus international is enough to represent their characteristics, then it's okay to use matching coefficient because it assesses similarity instead of 3 but 4 dimensions. So it gives us a more complete story.
So just so I have this straight, so on the Jacquard, you're basically saying it's because you're basically throwing that question out. It's the fraction is 1/3, well, 0.333. And then so it'd be better, the question C should be, the correct answer would be the matching coefficients is a better way because you could actually measure all 4 questions.
Yeah, you could interpret it that way. This question does not have the answer to this question depends on your reasoning.
Correct.
So as long as you make yourself clear and reasonable, then you give sufficient reason why you choose one over another.
Correct.
It's okay. I just demonstrated that you could explain why you choose a matching coefficient over Jacquard coefficient, and you can also choose to use Jacquard coefficient over matching coefficient, and both of these choices would have good reasons.
Do we still have time to ask questions, or we're out?
Oh man, I did not look into the time yet.
We're 15
Yeah,
minutes
it's already
over.
past 8. Okay, let's make it quick. What questions do you have?
Yeah, quick specific questions so we can be straight to the answer, which is question number 1F.
Okay.
How would you improve the regression model? Would you use what is it called? An order 5 polynomial? Would
Yes, you
do
could do that.
Okay. How can I know that this is the best fit as a model?
Good question. To understand whether adding a polynomial or square term is a good idea, we do another model to see whether this square term is significant or not.
All right. Well, thank you so much. That's it for me. I don't want to take more of your time.
Did I address all the questions? I see that in the comment area, there are many new messages. Okay. We just discussed the difference between matching and Jacquard coefficient, and there are also slides pointed out by another student about the difference, and always depend on your textbook if you want to understand the fundamental concepts. Do we include residual value in the values of regression equation? No, we don't have to, but it's a good practice to understand how the errors enters into the equation so that it helps us to calculate all the associated statistics. Well, feel free to unmute yourself if you want me to answer any additional questions. I'm currently looking in the meeting chat area.
Can you show us how to run a multiple regression model very quickly? Just maybe show us how to do a scatter plot.
Okay, are there 2 parts you want me to demonstrate? So for a scatter plot, It's quite straightforward, and I need to chop it and for only the 50 observations. Select the variables so that they must be adjacent, I believe. If you select one column with another column that does not stand beside each other, it probably won't work. Then to make a scatter plot, go to insert recommended chart, and all charts, there's XY scatter plot. Notice the difference between these two. Only one of them is makes sense. So select one that, so here in this case, the second option looks good. After making a plot, it's always good to check whether it's as desired or not, because sometimes the automatically chosen option does not give you the correct answer. So here we have a chart with some value on the x-axis and some value on the y-axis. And it's good to notice that on the y-axis, all the labels are already in $sign. So it's a good sign. If it's not, it's possible that you flipped the axes. So you would have to generate the chart again, or switch data or switch row and column to make sure that the dependent variable, the price, stands on the vertical axis. It's another good checkpoint to make sure the plot is done correctly by looking into the range. So in square footage, you can check the range to see whether they match what you observe, what you can tell based on the plot. So earlier, another student wanted to know how we can answer question part 1F about
Jerry,
whether, hi.
Oh, hi, I'm sorry. Can I ask a question? I put a trend line in it. It's just curiosity, and you go up to the right-hand corner
Yeah,
and you click
can.
and you put a trend line in. And then I clicked on the box and it said the option of getting the equations on the bottom. So I put in the trend line and by clicking the cross on the top right. No, on the graph, you go to the corner and you click on the positive, the first box, the first little box, and then you put in a trend line, and then you can get the equation. Could you calculate the price from that equation?
Yes, you can possibly do that, but I don't encourage you to it's still a good practice to do this modeling instead of depending on the plot, because first, the plot you draw may not be correct. As I said, if you flip through flip X and Y, it still gives you a trend line, but it may not tell you, it may not be correct. And the second is that doing the model gives us more statistics to calculate. And we can also refer to the coefficient when making predictions. But if you simply generate a trend line, and you can also display the equation, display R squared, but you cannot refer to the values inside of them. So,
Jerry,
yeah.
Jerry, can I just ask real quick? So
Sure.
just so I understand, I guess that I always got that confused. So basically you're saying that the model is the model that we did with the regression statistics and all that, not the graph, right? That's not the model. The model is the actual statistics, right?
Yeah, the model can be represented by a regression equation. It is shown here, but you won't be able to refer to any of these values. But if you use linear regression procedure in Excel, it generates a summary output, and you can refer to these cells.
Thank you.
Yeah, and it gives us additionally some more statistics for us to check the correctness and some properties. For example, using the number of observations, we know that whether our selection of the data range was done correctly or not. If you did not include, for example, the variable label row, the top row, you could still have a summary output table generated, but you may observe that this number of observations was instead of 50, but 49. So that means that we mistakenly omitted one of the observations.
Ah, got it.
And multiple regression would be done in a very similar way. So let's use the Microsoft example. Although this model, I'm afraid, won't make much sense because the number of variables we have is essentially just 2. So using this, we can do data analysis. Multiple regression is still in regression. So we select a Y range. For example, we estimate Microsoft price, raw price, and input X range would be these 2 columns. Let's see whether it works if I do not submit any row index. We should have they include the labels, and we should have a constant, that's the intercept. So we do not check constant, it's 0. So as I indicated earlier, it's possible that you generate all these additional statistics: residues, standardized residues, residue plots, and line fit plots, and normal probability plots. These are usually understood in other textbooks as diagnosis statistics. Anyway, it's not necessary for us to use them here. We can have the output in the same sheet. Well, it seems I would have to include the row index. Well, line, okay.
For X2, do we need to do D from
X2? Oh,
and is it D2 or is it D1? Oh, you said labels, so never mind.
yeah, I did. Let's see.
I think it should be D1 to D121 and then E1 to.
Oh, did I need to select in that way? Okay, thank you for reminding. Is it down this way? Okay.
And you add column.
Maybe.
And careful, I think it's D1 to D120.
Yeah, because we have the blanks.
Mm-hmm.
Good catch.
Blanks?
I think 2 values are blank.
Yeah, so it'd be D1 to D120, and then E1 to E120.
Yeah, I think that's what I have here.
Not 121, 120.
Oh, I see. That's probably
because you have empty cells at the 121 slots.
But I think you need 2 more columns.
Oh, thank you for pointing out.
You need
Let's
one
see whether it
column.
works.
1 column between 1 and 21 for each.
How do I column? Oh my God. How do I select the X input? Let me
There you
just
go.
redo it.
And don't get the blanks.
I see. Is it that sensitive? Okay, 120. Interesting. Oh, finally, okay.
Okay.
But I must highlight that this model won't make much sense. We are explaining the raw price index by using the percentage change of the same stock and the percentage change in S&P. But it gives us a model. That's it.
So you have two slopes.
Yeah, but as I indicated earlier, while we can always make a model for whatever data we have, only some of them are useful, and this is an unuseful case. For example, we notice that the R-squared, the adjusted R-squared, is a negative statistic. It means that this model does not explain anything. So using this model either to do prediction or to find the relationship would be not valid. And there are also good rationale behind it, right? We are in this model, we were trying to predict the raw stock value out of the percentage change of the same stock plus the percentage change in the general market. But the meaning of the raw stock value and the meaning for the percentage change in raw stock value are essentially different. So one can hardly explain another. That's why it's probably not useful to use such a model, although Excel would always give us some coefficient. All right, this should conclude our review session, unless you have additional questions. I hope to see you again next week. And remember that there are still very good additional resources you can use to understand more about regression and associated techniques in our week 2 and week 3 review notes. Some of them are beyond the course, so they are labeled as beyond the course.
Thank you, Jerry.
Thank you, Jerry.
Very nice seeing you, and I hope we had a great discussion.
Yeah, thank you, Jerry. Appreciate
I
it.
hope to see you very soon. Bye-bye.
Thank you, Jerry.